Hey there guys, and welcome back to the animation program. So this is a screen I don't think you guys have seen before, at least not on this stream is what I mean. And this is the Github Desktop App. And I'm going to be using this to go through the changes I've made and the tests that I made for the animation program, which I've been working on for the past, I guess week and a half or something like that right now. So, as I've been saying in the project updates, I have been implementing test case, and that's the first thing we will do. We'll go ahead and go over unit testing, since we haven't talked about that on the video or on the stream before, and there's VS Studio. So, unit testing, using the unit test package in Python specifically is pretty straightforward. So, basically, let's pull up actually PowerShell. Actually running the unit tests is very simple. It's just python-m and unit test, and that will automatically call unit test.discover, and that will find all the all the files that are named test anything testblob.py. And then it will look into each of those files and try to load from them test cases. And then after it finds all those, it will run them. A test case, and you'll see I make sure to go ahead and label everything, put all tests inside a folder called tests just to keep everything organized. But if we open one of these up, you'll see that these test cases are a subclass of unittest.testCase. At least that's how I make them at any rate. There's other things called, there's other types, other subclasses of unittest.testCase that you can use, but I find that very often to be not necessary. There are edge cases where you might want to use them, but 90% of the time you'll just subclass unittest.testCase, and this is the thing that it's gonna be pulling. There's also a unittest also has what are they called? Suites, test suites. You can also use those. Those are just a way of organizing the code. It's an option, but very straightforward. Inside of a test case, you just want to create functions that start with test, just T-E-S-T, and the test case will go ahead and take all those functions and pass them to the test runner, which is part of the discover function. You can also obviously create your own test runner if you needed to, and then that is how you run them. So again, it's an extremely straightforward thing, a straightforward process with Python unit test built in. And I've got a random import in here. Let me delete that from VS Code, randomly importing stuff. So yeah, it's one of those things, unit testing, not that difficult. It only comes down to specifics. So for example, let us find something, actually back over here, I think I have, is it an engine? No, I think it's in Sprite. So you very well may set up a test like this guy, where you do different stuff, and then you just keep calling self.assert whatever. They have a whole bunch of, unit test has a whole bunch of different assert functions that do different things. For example, assert equal. So first argument A is equal to second argument B. Very straightforward, makes sense. If this was assert less than, then we'd be expecting less than A, or A less than B would be what's calling. And that is basically how you test. You call these assertion clauses, these assertion functions, and then if it fails, the unit test will tell you. It will give you the error message, and it will tell you what function it's from, where exactly it failed, etc. What line number, so you can look it up. So that part is pretty easy. The more interesting part is over here. You can see that I have this whole entire list of tests here, and I've got this with self.subtest. And what this lets us do is, unlike over here in this function, where if this fails right here, this assert equals fails, the rest of the code will not run, because this raises an error. So because this raises an error, the rest of this is stopped. the nice thing with self dot subtest is that it will keep on trying to run the tests. Whatever code is in here, it doesn't have to be one line. It can be however many lines you want, but it will keep on running the code for each of the tests you feed it in. So if I make a list of tests here, any number of these can fail, and the code will continue to function. It will run through all the rest of them, trying to find ones that don't fail. So that is a useful function to know. These arguments inside of here are simply ways to denote what the parameters are that you're testing. So when self.subtest fails, it will give you as part of the error message, okay, these are the things that you passed into self.subtest, and these are the values that they had for the specific subtest. So if I fail on this guy right here, it will tell me, because I supply it with bbox1, bbox2, and result, it will say bbox1 was equal to -1, -1, 0, 0. bbox2 was 0, 0, 1, 1, and result was equal to -1, -1, 1, 1. So that way I can track down, okay, this subtest specifically is failing. Why are these attributes failing? And that's how you go about it. Again, it's just a very simple, straightforward way of working through it. Just create, basically, you test by deciding what the function is supposed to do, given a certain amount of certain input. So if I tell a sprite to move up, I should have expectations on what the result of that sprite moving up is going to be, and then I compare that sprite moving up using an assertion clause, an assertion function. I compare attributes, parameters, something like that, to what actually happened, my expectations versus reality, and that's how you test, which is why for functions like this, I have a whole entire list, because there's a bunch of different, if you read the, whoops, click off, there we go. There's a bunch of different situations that I want to test for that may fail. You know, they are somewhat unique. Now, it's one of those things you can be super particular, let's say, and try to get a whole, a majillion unit tests. That's generally not useful. You generally want discrete situations. You generally don't want to be repeating yourself. So, for example, some of these might not be necessary. I might have put a few of these in here that were already covered and would not fail, so long as, for example, so long as this one passed, this test right here should also pass. There's no reason why it shouldn't pass. So that's something to keep in mind, but at the same time, with as fast as this runs, the unit testing runs in general, assuming you're not doing really crazy crap, it's generally not a problem. It's generally not a problem to have extra tests in there. So, and I think also one other thing I wanted to mention, at this point, you can probably understand why I didn't want to do this on screen. You can imagine me sitting here and typing out each of these lines, copy pasting these lines, and then running the unit test every few cases I add to make sure it's working, and then going back and double checking, etc. So you can understand how that's repetitive and why I haven't streamed the unit testing at all. So yeah, I think that's everything I wanted to hit on, just our brief overview on how unit testing works. So I guess we'll hop back over to the GitHub page and grab something to look at, which the first thing at the top here, inside sample.py, you can see I made these changes, and this is a nice place to start because this is somewhat important and a good example of some of the things I did. So inside a hitbox, you'll recall we had anchored mixin, and we had, actually we didn't have anchored mixin, I'm sorry. We had the square hitbox, we had anchored square hitbox, and masked hitbox. So let me pull that back up on GitHub just so that we can see that visually. Hitbox, hitbox, hitbox. Where's hitbox? Sprites hitbox, there it is. So the red code is what we used to have. So square hitbox. This changed. How I did the anchors changed. We'll get to that. Masked square hitbox was different. And mask takes hitbox. Okay. Yeah, masked square hitbox turned into masked hitbox is what happened here. And the reason I did that, we'll start with that one, is that the mask, the size, the shape, and the size of the mask really doesn't matter. It can be anything, and I did a unit test which uses, let's grab that one just to demonstrate. That is up in samples, special mask. So you can see here, I actually made a mask that was a heart and put it on different places to overlay it, just to prove that it worked. There we go, this guy. So you can see there's the overlap of the heart on the, I think this is the right leg of the sprite. So this just proves that, you know, the mask doesn't have to be a specific shape and it will overlap. So that is why I changed that part of masked from what you may remember it being. The next thing, again, importantly, is the anchors. So the anchor I'm changed to an anchor mix-in. This is specifically right now for masks, but I'm thinking that we may even take this all the way out, because anchoring is something that anything can have. It can be the sprite, it can be terrain or background images. It could really be anything. Right now it is just in hitboxes, but it doesn't necessarily have to be that, and we'd want to formalize this code a little bit more if we did pull it out, but that's not something I've done. So the big change I made is that I changed how this worked. So before we had the, back over to GitHub really quick. Here's the right part. So you can see that we just did top right, bottom left, bottom right, center right, just as an if statement. I went ahead and turned it into individual letters that then get parsed out. And I added this function here, which basically just takes the input string and makes sure that it can be formatted into a 2-letter, a vertical and horizontal letter, to normalize it. So, for example, when we call top left, first we standardize our anchor, which comes up here. And for example, if our anchor is just T, that gets converted to top center TC. That way we always have 2 characters to work on. And then this is something that I was trying to do when we first set up the anchors, and I was trying to make it more complicated than this, and therefore gave up and just went with the if-else statement. But this, you know, is simple enough the way I have it right here that it should be understandable. We take the vertical. Actually, the vertical is the first, because top, center, bottom is the vertical keys. They affect the Y, and normally we say XY, so that's second, so it gets a little bit confusing there, but bear with me. It takes the vertical segment, which is TC or B for top, center, bottom, and then does the math on Y. It takes the horizontal segment, left, center, right, and does the math on that, and then it returns the XY. So that is very simple. It's not exactly what we did before with the else if, doing specific top left, bottom right, etc. It does break it into 2 parts, but it is still simple enough to understand, so I think you understand what's going on there. The other important thing to note is that before I just really quick threw it together so that the anchor for the mask was always top left. So the mask was always drawn from its top left corner, and then that top left corner of the mask got put on either the top left of the image, top right of the image, center of the image, etc. We've changed that now. I made that change, so now the mask and the sprite are both, the mask is anchored relative to the sprite in the same exact orientation. So what this means is that instead of the top left of the mask being directly on the center point of the sprite, for example, when it's anchored to center, it is instead offset half the mask width from the center, both in vertically and horizontally. So center actually means that the whole entire mask image is centered on the sprite. And then obviously just follow the same logic with top, bottom, left, and right. So if it's a bottom right anchor, the bottom right of the mask is anchored to the bottom right of the sprite, which makes a lot more sense, but that's not the way I did the first time because I just tucked it together. So this is obviously better. Now, this is in Mixin. It is not actually a class, as I stated. So we have to add the Mixin to the hitbox class, which I did here. And then, as I said before, this masked hitbox is just a generic masked hitbox, which means that our create rectangle hitbox function that we used to have got moved up here, just outside, so that it can be accessed wherever. Instead of calling square hitbox dot create rectangle create square hitbox image, which is what it used to be called, I changed it to rectangle because that is technically more appropriate, technically more accurate. So that is that. The last thing to mention in regard to masks is this opaque mask. I don't think I changed this before we got here, and I know for a fact I didn't change the code before we got here. So I moved it over to utilities. That code that used to be there, let me pull that up so that you can see it in GitHub. That was this code right here, imageops.invert, image point, etc., 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 convert dither, etc. So you may recall me talking about that one before and how we had to jump through these extra hoops to get the color changed over how we wanted to, because colors that were halfway through the 0 to 25 range were getting rounded to their closest interval. So I had some colors that were getting rounded to black and some colors that were getting rounded to white, when I wanted all the colors that were not transparent to just get rounded to black. Two things happen here, and we'll look at that inside of the utils function, or utils package rather, module. Opaque mask. So first off, you can see here, I'm actually iterating over the pixels myself to determine the color. When I tried to do this before, this is actually the first thing I tried to do, but I was iterating over the actual pixels instead of iterating over a range, and that was taking forever, which is why I didn't do it, which is why I went to dot point, the dot point function. I was looking around Stack Overflow and I found out that this actually runs plenty quick enough, accessing the pixels by index. So that's what I switched to. The next thing to notice is that our masks are now, the masked portion is now white. And the reason the masked portion is now white instead of black is because I went back to doing logical AND. When I went and created this function at first and couldn't remember how exactly I did it work, if you recall that stream, I started with logical AND because that made sense in my head, but I wasn't getting the results I wanted because I was doing it a bit wrong. The problem with difference is that it doesn't always work with the way you expect it to, with depending on how the image is set up. The logical AND always works because you're checking specifically for white pixels in both in both images, in both overlapping images, which in this case, in our situation, is very often two masks. So when two masks overlap, when both of them have the white pixel, the one, that is when it is selected. And that is exactly what we want. So that's why I changed it back to logical AND instead of going with difference, image shops dot difference. Next thing that you may notice is this dot crop right here. Before we're sending back the full size image, so when we had, let's say I have a 25 by 25 sprite mask, and it's only overlapping the top left corner of another sprite mask that's, let's say, 25 by 1 pixel, then my resulting image that I was sending back here was, that would be 49 by 49. Yeah, that's 49 by 49 if I'm going directly corner to corner 1 pixel. So that is a lot larger than either of the masks, and I decided to just crop that down to the first image. Whatever this first image is, and wherever that first image is, that's the area that we crop out and send back. So this is also useful because it means that if we want to see what specifically the mask we're worried about overlapping is interacting with, we know exactly where that is. We don't have to then go and select the area that mask is occupying inside of this big image that we sent back. We don't have to go back in and trim it ourselves. It will automatically trim it to exactly whatever that mask is. So that's why I made this change here. The check bounding box overlap. This was actually back in Engine is where it used to be. Utils. So this used to be up here. It was a generic function, and therefore I decided, since it's a generic function, I should just put it in utils instead of inside Engine rather. So now we can check any bounding boxes, just not for the engine, not reserved only for the engine itself, which is useful. The other thing, and let me pull up GitHub now to show you the difference. That was originally, like I said, in engine.utils. So before we were checking the corners, I drew out this map and I said, hey, look, if the corner is in there, then if the corner is in between two other corners, then it works just fine. Then it's contained, it's overlapping. That's how we did the function before. We compared corners to the other corners to see whether or not it would fit. The problem with that is that I wrote some test cases, and when two of the edges, so for example the top and the bottom edge, overlapped, because we're just using not greater thans and not equal to, that would not count, because the top and the bottom edge are overlapping, but they're not, but they are equal to, the edges are equal to each other. The top edge of one bounding box is equal to the top edge of the other bounding box, and vice versa. That means that it wasn't matching, and then if I changed it to greater than or equals to, then we get a bunch of false positives, which broke it. So I spent some time playing around with sticky notes at work while I was working on this on my lunch break, trying to figure out how else I can define this. And I made a realization, so I just turned the lights on, and now we can switch over to camera so we can look at this. I was doing exactly this right here. I was going like this, and my first idea was just to find the area of any overlapping spot. Just try to see if I take an area, if I use two corners from each of the things, if they create a square, if those two corners create a square and it has an area, then that would be an overlap. If there is zero area and it somehow makes a square, then that is not an overlap. That was my first idea, but as I was playing around with this, and actually, while we're here, let me just clarify. So this is the situation that I was talking about before with edges being equal. So even if this guy is a bit short, so this guy is shorter, so only these two edges are lined up. Because these two edges are both equal, that means that our previous function was not working. So this is the situation, as you can see, that was failing my unit test, which is why we do unit tests. But what I realized as I was doing this is that we always reference one corner to draw our bounding box, right? So what that means is if this corner, if the top left corner, let me move that back into camera. So since we're always drawing our boxes, we start our bounding box here and draw it down here. And same thing with this guy, we start our bounding box here and draw it down here. If this corner, this top left corner, is ever to the right of the right hand corner on this guy, then there is literally no way, no matter if I move this up or down, there is no way for it to be overlapping. And the same thing goes with the top edge comparison. So no matter, so long as this top edge is below the bottom edge of this guy, no matter where I move this left to right, it doesn't overlap. And the reverse is also true. So if I just do this in reverse and look at this guy's top left corner, if this top left corner is to the right of this guy's right edge, or its top left corner is below this guy's bottom edge, it's the same exact situation, right? So I just got to check two edges, check these two edges, and I just do it for both slips, both bounding boxes. I check this direction here and here, flip-flop them, check this direction here and here, and that's good. That should work. That should be all my unit test cases that I need, and that did work. So let's go ahead and look at that really quick, what that looks like in code. So here I have my boxes, and AXO and AX1 would be my X's would be my top, my left right top edge. That would be my top edge. So here we have that comparing to the bottom edge. Yeah, that's right. So x00 is my top left x, right? So if that is greater than the right-hand side, the bounding box right-hand side of B, then it is to the right of the bounding box, and then this is the flip-flop. And then this is the top edge. This is the top edge. This is the Y of A. And if that is below, greater than the bottom edge, the bottom Y of B, and flip-flop. So that's how that works out, and this works a lot better. And by a lot better, I mean exactly how it's supposed to work. So that is our fix here for this check bounding box situation. Let's hop back to GitHub and look at some other stuff. So all these test samples you see here with PNGs and bitmaps, that is just because we're unit testing visual things with pixels. It's one of those things. I could have saved them technically as arrays of pixels and just compared to the arrays of pixels. I saved them as actual images. That way, as a human, I can look at them and see, okay, this is the expected image that I'm supposed to get. If I just go through the file structure, so minimize this really quick. If I'm just looking at a function right here, so test hitbox, and I see that it references mask 1B, this is the result right here, the result image that I'm expecting to get. Me as a human, it's very easy for me to come over here to the file structure on the left hand side and click it and just see what that's supposed to look like, right? So that's why I did it this way. Again, this technically could be a just a whole bunch of data. So that's one of those things. It's just an easier thing for me as a human. It could have been data, and I could have just had a file that contained all the data instead of all these different bitmaps in here. So that is the situation with that guy, why those guys are there. Let's see, what next? Next up, I want to do the sprite, the changes I made to sprite, because I made a pretty interesting change to sprite, and it had to do actually with the engine. So since we were just talking about engine, it segues pretty good. So in here in engine utils, I was running into it. We were having a problem finding collisions was our problem, right? That's why I started unit testing, because my character was running through the desk, right? Which was a problem. And you'll see right here, I added this target sprite.at. And the reason I had to add that, I realized that we were checking where the sprite was at the time of the call to this collision stop rule. So to refresh your memory, canvas goes to make a movement. The canvas object, technically the engine would be doing it, but we're doing a GIF right now, so there is no engine. So the canvas moves the sprite and then calls the move back event for all registered listeners rather. And this is one of those registered listeners. It gets the movement event, and then it looks at the movement event. So that's the context of where we're at right now, just in case you need the refresher. So this movement event callback listener was not actually updating where the sprite was going to be after it moved. So it was sitting there saying, oh, your sprite is standing right in front of the desk. So it's not running into the desk, right? Because I'm not considering the fact that it's about to move. What I could have done was done target sprite dot location equals, well, actually start location equals x target sprite dot location, and then new location right here. Well, actually, since I already have these variables right here, target x, target y, target x, target y, and then at the bottom here, before we exit, before we return false, and before, so both right here and down here, we set target location equals start location. That would have been the way to do it, right? That would have been a way to do it. Just move the sprite to where it's going to be, check whether or not it has a collision, and then move it back before you exit. But I went a little bit fancy with this guy. And I went ahead and implemented back to sprites, because again I implemented this in Sprite. There it is, init. This is the test case. There we go, init. I implemented this start location, and this is a class specifically because I needed these enter and exit context managers. We've talked about context managers before. So again, when we enter, when we use with x being whatever class instance we're entering into, when we use that, when we use that with statement, it fires this code, it activates this code, and then when we exit the with statement, when we dedent back out, it runs any code inside of exit. And what this allows me to do then is, let's go ahead and look at the unit test. Here we go. So here's the test case. So with sprite dot, this sprite here is not a specific sprite, this is the sprite module. So with sprite module dot start location, and I'm passing it in my sprite right here called S. We can set the location, and then when we come back out to location, the location is unset. And this is one of the nice things about writing a bunch of test things, because if you don't understand how a function works, instead of reading over the function, you can look at the tests that were written, and that can give you some context on what the function is supposed to be doing, because again, the test functions are supposed to be making sure that the function is functioning the way it's supposed to function. So that gave me this little context manager here, which is what I wanted. And I added just some extra features. So for example, start location can just have a revert. Well, it has a revert function, I should say. So if you wanted to use start location without the enter and exit part, you could call it, do a whole bunch of stuff, and then later on call .revert on start location. And it will go ahead and do exactly the same thing. It will move the sprite back to the location it started at. And then I went ahead and implemented this function right here, which is very simple. It is sprite.at, and it just returns a new start location. So hopping back over here to the test cases, you can see that test at context, we can have a sprite called S. Its location right now is 0, 0. And then we can use the verbiage with S sprite at none. And I really like how this worked out, because this is very what we call Pythonic. It makes sense when you read it in English, exactly what it's going to do. So my sprite, let's call him Fred, with Fred at 0.100, 100. So in the context of this conversation, we're pretending that sprite is at Fred is at 100, 100. You know immediately what the function is supposed to do, and without even having to read the documentation, right? It makes sense. So I was very happy with how this worked out. So now we have this at function, which allows us to move the sprite temporarily to another place, do some stuff with it, and then when we're done, when we exit out of the with statement, the sprite will be moved back to the place it started at. So I was very, very happy with how that turned out. And we can hop back here to the collision stop rule, and you can see that's how we used it. So during the event, while we're checking the event for collisions, inside of this with statement, we move the sprite to the target location, to the location it's supposed to be, and for all this code in here, that's where it's at. But the second we leave this code, either by returning false here or naturally dedenting at the end of this with statement, the sprite gets whiplashed back to its original position, back to its quote-unquote current position, so we don't have to worry about doing that ourselves. So that is a very important change that, again, worked out very well and did us a lot of good. So let's open up GitHub again. There it is. I did not close GitHub. Cool. And let's see what else what other changes we made. Here's unit test. Oh, actually, you know what? One thing I wanted to mention, speaking of unit tests, when I implemented sprite.startLocation, I told you before that I prefer to, where's this at? Sprites input. All right, there you go. I prefer for for programs like this, for modules like this that are this complex, to do test-driven development. That's exactly what I did for this guy. So The very first thing I did before I even created start location, the start location class, before I even did that, I wrote test set initial, test set location, test revert, and test context. I wrote these 4 functions, and then I wrote the descriptions of them. I wrote the description of them next and said, okay, this is what these are supposed to do. And then I hopped back over to Sprite. I started writing some stuff just because I wanted to make sure I knew how I was doing this, because I didn't want to write some test code that was not going to be the exact text code I was going to end up with. So I wrote, for example, the init right here. And the second I had the init done, I came back over here. And not back over here. I don't have it open right now because it's not staying open. I came back over here and I said, okay, I wrote this much. I said sprite.startLocation equals that set it equals. So this is supposed to work when I initiate the class. When I initiate the class, this should work. And then I went back over to Sprite. After I was done that, after I ran that test and made sure it worked, I went ahead and actually I didn't even go back to Sprite because I already had the Sprite class written. So I then set up this first set of code right here, which was, okay, I want to add a location, a new location parameter to the Sprite class. So before I do that, I'm going to go ahead and write this test code. And that's how you do test-driven development. You, where possible, write the test first, and then come back and write the code that you want. And I wish I just hit the keep open button so I don't have to keep on coming to the file system to find it. So I had the test code written, then I came back over here and said comma new location equals, and originally I had none, and I realized none is not a good idea because, again, Sprite location can be none, we decided. We didn't actually decide that. That's something I modified really quick on the sly without you noticing. So I had to create this null object right here just to have a placeholder. Again, Sentinel values are something that there's an open PEP Python enhancement proposal. Python enhancement proposal is what it's called. There's a PEP open for Sentinel values to create actual Sentinel values, but this is the way we do it right now if we really need to. Otherwise, you can also use enum if you wanted to. That's the other way to do this. So I could have started an enum file that just keeps track of all random values that I want to have enumerated, and I could have done it that way. So that's 2 different ways. But if new location, I came back over here, point being, if new location is not start location dot null, as in is not is different from the default parameter, is in other words what this means, then set this. And then I ran the test, and the test happened to work the first time because it's a very simple implementation. And then I said, okay, I'm going to need to be able to revert this because that's the whole entire point of the class. So before I wrote define revert, I came over to here to tests and filled in the code here. And then I wrote .revert and etc. Again, moving on throughout the rest of it. And again, this just emphasizes how tedious testing can be. I don't mind it. It makes me feel comfortable because I'm somewhat paranoid, but it can be a bit tedious. One thing that I will mention is that just doing this much is not necessarily good enough. It is good to start with, but I really should try to break revert, let's say. I should probably put some thought into what are ways that I can break this revert function and try to write some test classes to test whether or not the function actually breaks. You know, can I pass something to start location class that causes revert not to work? And then I'm going to have to go back in if it does fail the test like that and fix the code so that it doesn't fail the test anymore. So that's another important thing about unit testing that I want to mention that has been on my list of things to mention. So back over to GitHub, which is where we were at before. Canvas. Looks like, oh, trigger event. Okay. So I took out of the for callback and self the events and moved this over to trigger events. So trigger events, very simply, for callback in self.events event name, yield callback. The yield part is because this is a generator. You could do output equals for result for callback or callback. Okay. Output equals open brackets. We're doing a list comprehension. Callback event object for callback and self.events event name. That's the way you could do it, and then return output. That is not as useful because in this situation right here, as you can see, if our response is false, we want to return. So we actually don't want to generate the whole entire list if possible. If possible, if the very first event that we call says, oh wait, hold on, don't do that, cancel that movement, we want to cancel as quickly as possible. If we did the list comprehension, it would call everything, and we might have 3 or 4 different callbacks that are saying, no, do not return. Do not do that movement. Do not complete that action. Whatever we're doing right now, whatever triggered this event, we would get all those things telling us no, and we only needed one of them. We only needed one of those things to tell us no, and we would have stopped, and we wouldn't have wasted all that time. So that is why this is a generator right here. Otherwise, it does, like I said, exactly what this thing would have done right here. So that's not that complicated. The other reason to move it out here, well, actually the only reason to move it out here, no, there's 2 reasons. I take it back. There are 2 reasons. One, if I ever need to change this code, then I don't have to come into move sprite. This is the move sprite function. I don't have to come in here to the move sprite function, change this, and then also change it at like add sprite, for example, if we have a callback for adding sprites to the canvas, which is a reasonable callback to have. I don't have to also change it over there, so I can just change it here. That makes things easier. The other thing is that this makes this easier to test. So inside of the unit test for this guy, that was under canvas, right? Canvas. There it is. Canvas is tests init. And I apologize for the knocking if you can hear that. Let's see. Here we go. Test trigger event. So I was able to just test the trigger event with random events. You can see here, this is my event. It's just the event that I'm calling. So it made it easier to test the whole entire event chain. So that's the other reason to move it out. Okay. Oh, shoot me. I did not minimize GitHub. I apologize. After I was talking about this trigger event, I just pulled us up into the event. This is what you just missed right here. It was just me looking at this and saying, here's the test trigger event. There you go. That's what you missed. Good thing I caught you relatively early there. So now back to GitHub. Again, my apologies. Let's see. That was canvases. We didn't have anything else in there. Test utils. This is the engine test. So we already talked about that guy. I already touched on these guys right here. That was not that big of a deal. Let's see. The bounding boxes we touched on. This result.show was me trying to figure out why we weren't finding collisions. So that's obvious why that one disappeared. This is start location. You guys know about that guy. Hitbox. We talked about the square hitbox being moved out. And that stuff. And the overlap images. Oh, this right here, just for the record, because we cropped the image on find overlap images now, I changed the order here from sprite first to mask first, because we only care what the mask is overlapping. So that's an important thing to note. I kind of mentioned it, but kind of also didn't point out that it was important. Those are all images right there. Test hitbox. Let's see. This is all the anchor tests right here. Just very straightforward. This is make sure that it standardizes correctly. So these are all the possible codes on the left-hand side. I went ahead and enumerated all the possible codes instead of just taking a selection, because I figured it's a finite amount and therefore it's fine to test. The finite amount. This is not an arbitrary number. This is an exact number that is exactly all the cases. So it's not that big of a deal to test. If I was only going to get a random selection of anchors because there was an infinite number of anchors, then I would not rate this many. I'd only write, like, let's say 8 of them. Okay? Just to get a general idea that it's working. And then if one of them wasn't working, I found out later on, I would fix that. So this is top left, which just tests the anchors, I believe. Well, I mean, it tests top left, but we changed how the anchors worked, and it just tests the anchor, that the anchor offsets the top left correctly, so that's not that big of a deal. Again, this is just the masking stuff, so I touched on that stuff. So let's move on. Test utils. Yeah, we talked about bounding boxes, so that's cool. This is not something I talked about. Let's hop over to, and I won't alt tab, I will minimize. So inside of the top level test right here, I have utils. You'll notice this is not test underscore utils, because this is specifically a number of utilities for test functions, just generally throughout the whole entire module. So this gives me stuff like a uniform way to load the test sprite, so I don't have to, in every single time I want to load a test sprite, navigate to samples folder, find it, split it out, etc. This allows me to just call for any test case that needs a sprite. It's just a simple way for me to get a test sprite to use. And it also has these constants right here that I can reference. Again, that is just to make my life easier for testing purposes. It saves me on a whole bunch of code. The load terrain sprite just loads the desk up, and then load canvas, obviously just a generic canvas, just a 500 with step length, no big deal. And then obviously some hitboxes, some generic hitboxes that I can use for any test case I want. And that would be all the changes. We hit the bottom of the list. So I wanted to get this done in less than an hour. We got it done in less than an hour. The program is back up and running, so we are good to go with more development in this. We have collisions now. The next thing that I wanted to do was a basic AI and pathfinding. So that is the next things we will be covering on the stream animations module development whenever that comes next. Obviously, I have a bunch of different projects queued up in line to stream that I've been working on the past 2 weeks. Again, the past 2 weeks have been less streaming and more just getting these projects in line so that I can actually show them to you. So look forward to that. Again, the big project that blew up last weekend and I wasn't able to stream should hopefully be fixed at this point. I actually just need to make the last couple of touches and plug it in to make sure it's working. And if that is working, I may stream it as early as tomorrow afternoon, maybe Friday afternoon. We'll see what happens. I have half days tomorrow and Friday because of summer hours and because of the holiday coming up. So I will have extra time for streaming over those 2 days. And otherwise, the conductive epoxy tests are coming up. I unmolded the one piece today. I want to give it an extra 24 hours to make sure it's completely cured, because this time I'm actually going to put it on the router sled and mill the top of it to get the top flat, see how that does it with conductivity, and then if I need to, because that's probably going to leave a pretty smooth edge, so if I need to, then I'll hit it with the 60 grit sandpaper again. I did not notice a difference. I didn't mention this when we were talking about it last, but I did not notice a difference between the 60-80 and the 120 grit sandpaper, so probably just going to stick with 60 from now on. And then after I do the big screen, just backtracking. Oh, actually, before I backtrack, the mini CNC machine. I was going to print out the parts to do the Y-axis, just so that I had that to show you guys before we designed the Z-axis. And then I looked at my filament and went, you know what? I want to see if there's any other filament any other color filament that I think might look better. I found this nice reddish purple that I think will contrast really well with my silver extrusion. So I went ahead and ordered that, so that will be coming in, and then I'll print out the parts, and we'll have the Y-axis assembled for the next time we start working on the Z-axis. So again, look forward to that guy. And now for the backtrack. Obviously, as soon as I have this big video out for the big project I've been working on that blew up, as soon as that's done, we have a whole slew of projects that I want to work on after that. So again, it's going to be a very busy next couple of weeks to make up for the fact that I did not stream as much last week as I wanted to. So that is everything from me. I did make it in under an hour. I wanted to make sure I had this done in under an hour. So if I was talking quick, that's why. Because somebody here has been getting like 5 hours of sleep a night, and somebody wants to go to bed reasonably early tonight. So All that being said, wherever you are at in the world, thank you for watching, and I hope you have a great and wonderful day, afternoon, or evening wherever you're at in the world, and I will catch you next time.